Hello friends, welcome back to IQNest. In today's video, we will be discussing about one of the important and integral topic in science, that is chemistry. So in this video, we are going to discuss about some basic and fundamental concepts in chemistry that you might have studied in your high school classes. However, these concepts are really important because many questions are being asked from these concepts in various competitive examinations. So before we start, a few words. If you are watching our channel for the first time, please subscribe our channel and support us. Also, please do watch our previous videos on various topics and build up your knowledge. So without further delay, let's start with today's topic, Fundamental and Basic Concepts in Chemistry, Part 1. The first point is, who is known as the father of chemistry? The answer is Robert Boyle. The second point, who is known as the father of modern chemistry? The answer is Antoni Lavoisier. So please don't be confused with these two questions. The first one is father of chemistry, that is Robert Boyle, and the second is father of modern chemistry. The answer is Antoni Lavoisier. The third point, law of conservation of atomic mass was suggested by Antoni Lavoisier in 1785. Next, law of constant composition was stated by French chemist Joseph Prost in 1794. Next point is, law of multiple proportions was stated by John Dalton in 1803. John Dalton also first postulated the atomic theory. So till now we studied three major laws, that is law of conservation of atomic mass, law of constant composition, law of multiple proportions. These three laws are really important and question can be asked about these laws and who suggested these laws. So please remember these three laws. The next one is Avogadro's law. So what is Avogadro's law? So Avogadro's law states that equal volumes of all gases under the same condition of temperature and pressure contain same number of molecules. So that is Avogadro's law. Next, what is Avogadro's number? Its value is 6.022 into 10 raised to 23. So that is the Avogadro number. The next important point is, what is atomic mass unit? It is also known as AMU and it is defined as the 1/12th of the mass of a carbon atom. Okay, so that is atomic mass unit. And one atomic mass unit is equal to mass of one C12 atom divided by 12, and it is equal to 1.66 into 10 raised to minus 24 gram. And atomic mass unit has been replaced by U, which is known as unified mass. So earlier it was known as atomic mass unit and it was later replaced by a term called unified mass and it is notated as U. And what is mole? The amount of substance containing Avogadro's number of particles is known as a mole. And what is molar volume in standard temperature and pressure? It is 22.414 liter. So that is the molar volume as STP. And the next point is, what is molarity? Molarity is defined as the number of moles of solute dissolved per liter of solution. That is known as molarity. And what is the equation for molarity? Molarity capital M is equal to number of moles of solute divided by volume of solution in liter. So that is the molarity equation. Next is, what is molality? Molality is defined as the number of moles of solute dissolved per kilogram of solvent. And equation for molality is molality small m is equal to number of moles of solute divided by mass of solvent in kilogram. Next, what is normality? Normality is defined as the number of gram equivalent of solute dissolved per liter of solution, and equation for normality is normality capital N is equal to number of grams equivalent of solute divided by volume of solution in liter. So please remember these three terms, molarity, molality and normality. So question can be asked about these three terms and you should be aware of the equations of these three terms. And next, what is an atom? An atom is the smallest particle of a substance. Atom comprises of three elements, that is protons, neutrons and electrons. Atom was discovered by John Dalton, and the first atom model was created by Niels Bohr, and the term atom was coined by Oswald. So 3 points. So the atom was discovered by John Dalton, and the first atom model was created by Niels Bohr, and the term atom was coined by Oswald. So there are three major names related to the atom. Okay. The next point is about electron. So electron was discovered by J.J. Thomson by cathode ray discharge tube experiment in 1897. So the electron was discovered in 1897 by the scientist called J.J. Thomson through cathode ray discharge tube experiment. The term electron was proposed by Johnston Stoney. Robert Andrews Millikan determined the charge of an electron as 1.602 into 10 raised to minus 19 coulomb through oil drop experiment. So that is the charge of an electron. The value is 1.602 into 10 raised to minus 19 coulomb. J.J. Thomson calculated the mass of an electron as 9.1 into 10 raised to minus 31 kilogram. So you should remember the charge of an electron and mass of an electron. The next point is, an electron is the lightest fundamental particle of an atom and they are negatively charged. So the charge of an electron is negative. The next point, Goldstein detected the presence of a proton using discharge tube with a perforated cathode. The term proton was named by Rutherford. A proton is also called as identity card of an element. So, which is called as the identity card of an element. So, the answer is proton. A proton has a unit positive charge of 1.602 into 10 raised to minus 19 coulomb and mass of 1.672 into 10 raised to minus 27 kilogram, which is equal to that of a hydrogen atom. So earlier we studied that the electron has a negative charge and here the proton has positive charge. The next point, James Chadwick discovered neutron. So this is the third element in an atom, that is neutron, in 1932. Neutron is the heaviest fundamental particle of an atom and it is the least stable particle. The charge of a neutron is 0 while mass of the neutron is 1.675 into 10 raised to minus 27 kilogram. So the charge of an electron is negative, charge of a proton is positive and charge of a neutron is 0. The next point, Anderson discovered positron in 1932, which is the positive counterpart of electron. So what is the positive counterpart of electron? The answer is positron. The next point, nucleus, which is the central part of an atom, has positive charge and was discovered by Ernest Rutherford. Proton and neutrons are present in the nucleus and electrons revolve around the nucleus in definite paths called orbit. So nucleus is at the center of an atom and nucleus consists of protons and neutrons and electrons revolve the nucleus in a definite path called orbits. Now we will be seeing an atom model. You can see the atom model with the nucleus at the center and different orbits around the nucleus, and you can see the electrons revolving in the orbits around the nucleus. So the maximum number of electrons that can be accommodated in a shell is 2n square, where n is the shell number. So you can see the different shell number k, l, m, n. So the K shell consists of 2 electrons, L shell consists of 8 electrons, M shell consists of 18 electrons and the N shell consists of 32 electrons. Protons and neutrons are collectively called as nucleons. So there is another name for it. Protons and neutrons are collectively called as nucleons. Atoms have a neutral charge electrically, as the number of electron is equal to the number of protons in its nucleus. So since the number of proton is equal to the number of electron, this positive and negative charge cancels and the atom have a neutral charge. Next point is about the mass number, atomic number and atomic symbol. So the atomic number Z is the number of electrons or protons in an atom, and so the atomic number is notated as Z. The next is mass number. Mass number A is the sum of the number of protons and neutrons present in a nucleus of an atom. So the mass number is notated as A. Atoms of same element having the same atomic number and different mass number are called isotopes. So we studied about the atomic symbolization and how we symbolize mass number and atomic number. So if atoms of same element are having same atomic number and different mass number, so these are called isotopes. For example, 1H1, 1H2, 1H3. So these are the atoms of a same element called hydrogen, and which are having same atomic number but different mass number. So 1H1 is the protium, 1H2 is the deuterium, and 1H3 is the tritium. So these are isotopes of hydrogen. Next, the term isotope was introduced by Frederick Soddy. Next is atoms of different elements having same mass number but different atomic number are called isobar. So for example, 1H3 and 2He3. So H is hydrogen and H is helium. Both of these elements have different atomic number but the mass number is same. So since because of that, these are called isobars. The next is atoms of different elements having different atomic number and mass number but having same number of neutrons are called isotones. For example, 16S36, 17Cl37, 18Ar38, 19K39 and 20Ca40. These all are isotones of 20 since they all contain 20 neutrons. So these elements are having different atomic number, different mass number, but if you subtract this atomic number from the mass number, you will get the number of neutrons which is equal to 20. That is, all are same. So that is called isotones. The next point is atoms, molecules, ions containing the same number of electrons are said to be isoelectronic. So the atoms or molecules which are having same number of electrons are called isoelectronic. So till now we studied 4 different terms: isotopes, isobars, then isotones, and the last one is isoelectronic. In the case of isotope, the elements are having same atomic number but different mass number. In the case of isobars, the elements are having different atomic number but same mass number. In the case of isotones, the elements are having different atomic number and mass number but having same number of neutrons. And the last case, for the isoelectronic, the elements are having, or atoms are having, same number of electrons. So that is the difference. And for an example for the isoelectronic, you can see O2 minus, F minus, Mg2 plus are having 10 electrons and are hence isoelectronic species. And in the last part, we will be seeing all the summary of electron, proton and neutron, and we'll see the relative mass, charge and who discovered these elements. So the first one is electron. Its relative mass is 0.543, absolute mass is 9.1 into 10 raised to minus 31 kg, and the relative charge is -1 unit, and the absolute charge is -1.6 into 10 raised to minus 19 coulomb. And the electron was discovered by J.J. Thomson and it was named by Stoney. And in the case of proton, the relative mass is 1.00763 AMU and the absolute mass is 1.673 into 10 raised to minus 23 kg, and the relative charge is plus 1 unit, and absolute charge is plus 1.6 into 10 raised to minus 19 coulomb, and it was discovered by Goldstein and named by Rutherford. And the last one is neutron. The relative mass is 1.00863 AMU, and the absolute mass is 1.675 into 10 raised to minus 27 kg, and there is no relative charge, and absolute charge is 0, and the neutron was discovered by James Chadwick. So friends, that's it for today. If you like this video and if you feel that this video is informative, please like it and subscribe our channel. Also, please press the bell icon so that you will get the notification for all the new videos that will be uploaded in this channel. So I will meet you again with another informative video. Thank you for watching and have a good day.